Sometimes we will have problems that we cannot solve by factoring. Take for instance this one. This one's in a special format. We don't have an x right here beside the x squared. So we simply have the x squared minus 3. It's not in the format we're used to seeing, which is in the form of ax squared plus bx plus c equals 0. We're actually missing the b part of this equation. When you see one that's like that, the easiest way to do that one would be to use the square root principle. And what you do when you have one that's like that is you simply move the constant term, which is your minus 3, to the other side. And remember, when we move to the other side, it changes the sign. So we end up with x squared equals 3. We then take the square root of both sides. So the square root of both sides of the equation. When we take the square root of x squared, we get an x. Now, you have to be careful here because when you take the square root of a number, you actually get a plus and a minus of that number. For instance, the square root of 16 is not just 4, it's really plus and minus 4 because 4 squared is 16, but negative 4 squared is also 16. So when we have one of these, we have to put this notation beside our answer. And if it was something that we could break down, we would break it down. So, like if we had a problem that was like this one, x squared minus 45 equals 0. I would still move the 45 to the other side, and I would take the square root of both sides, giving me an answer of x equals plus and minus the square root of 45. Now, the square root of 45, though, is not an accurate answer because the square root of 45 can be simplified. I don't know if you remember this from past classes, but what you do is you take the 45 and you draw factor trees. And since this is square root, there's an imaginary 2 out here. So we're going to look for groupings of 2 numbers. If it were a cube root, there would be a 3 out there. Fourth root, you would be looking for 4 numbers. Since this is square root, we're looking for groups of 2. So a 3 gets to come out because there are 2 3's, but the 5 has to stay in there. So the final answer for this one is actually plus and minus 3 square root of 5. You could also use your calculator and punch in the square root of 45 and get a decimal for that answer, but you would not leave the answer as the square root of 45. You may also have problems that don't necessarily meet the criteria we just talked about. In this one, the problem does have that x value right there. It has a negative 6x, but it's still not in the format that we're used to in that it's not set equal to 0. So we're going to need to bring the negative 2 over and set this problem equal to 0. Now the most obvious choice to solve this one might be by factoring, and since there's a 5 here, we would probably need to use the AC method. So we would say 5 times 2 is 10 and try to find factors of 10 that give me negative 6. Well, the factors of 10 would be 1 and 10, 2 and 5. There are no factors of 10 that give me negative 6, so I can't factor this one. If it's a problem that can't be factored, then you're going to have to use the quadratic formula. This is your quadratic formula, and remember we talked about our problems being the form of ax squared plus bx plus c equals 0. So those numbers that are in front of the x's and the number that's by itself, those would be your a, b, and your c. So in this problem, a would be 5, b would be negative 6, and c would be 2. And we simply plug those numbers into our formula. So here all I've done is plugged negative 6 in for b. Notice that your formula has a negative sign right here, so I've used that in my problem. And when I plugged in b, I plugged in the negative 6 because there is a negative sign in front of that 6. So you're just going to plug everything in. I've plugged in -6 for B, I've plugged in 5 for A, and 2 for C. So when we do this, we just need to do our math. We have a -6, that's going to be a +6. This one's going to be a 36, and this was going to be -20 times 2. So let's just do our math. Now, in most cases, the number under the radical is actually going to be a positive number, and you'd be able to work with that. In this case, 36 minus 40 is a negative number, so you could stop and actually say no real solution if you get something that's like that, but I'm going to go ahead and finish it because the answers in the back of the book are finished. But for your test, if you see one that is negative, if this part's going to end up being negative, you can stop and say no real solution because we cannot normally take square roots of negative numbers. Now I'm going to show you how to finish it because you would finish the positive ones in that way too. So in this one, 36 minus 40 ends up being, let's see, -4. So we're going to put a -4 under our radical. Anything that has a negative number under it, we're going to call I, because the square root of -1 we define as I. That's just the definition of it. The square root of 4 has always been 2, so we're just going to call this 2I. So if you had a -16 under there, you'd call it 4I. If you had a -20 under there, you'd break down the 20, and I'll do a problem like that in just a minute so you can see. But this one would be 2I. It would look just like that. And if the three numbers have something that's in common, you can actually reduce them. So this can be reduced by 2 because 2 will go into all those numbers. 2 goes into that one 3 times. 2 goes into that one 1 time. And 2 goes into that one 5 times. So your actual answer to this one would be 3 plus and minus I and the whole thing over 5. Now let's just look at some things that could pop up in your answers. The basic thing about the quadratic formula is you need to make sure that you can put your A in for A, your B in for B, and your C in for C and get the right answer. But sometimes these problems, when you actually plug them in and you start doing the math, you have some things that can happen, and I'm just going to show you some things that can happen. The first one we already talked about. If you get a negative underneath the radical, you can stop and say no real solution. But sometimes you get positives under the radical. Let's say you get something like this as an answer. 11 can't be broken down anymore, so you would stop there. There's not three numbers in a triangular formation that you could reduce, so you can't even reduce this. I know that 2 will go into 6, but the line goes all the way across, so the 2 has to also go into some number up here, and there isn't a number here. So we can't do anything else with that you would leave that answer in that final form. Here's something else that could happen. Let's say you get something like 45 underneath there. You can break down 45 into 9 times 5. And 9 can be broken down into 3 times 3. Since this is square root, we have that imaginary 2 there. We're looking for groups of 2 numbers. So a 3 could come out and a 5 would need to stay. We again have that triangular shape, so we can reduce this problem by 3. And our final answer becomes 2 plus and minus the square root of 5. We don't need to put the 1 because it's underneath it, it's the denominator, and when you have a denominator of 1, you don't need to put that. So again, our final answer would be 2 plus and minus the square root of 5. If this had been a -45, then we would have an I out here in front of the square root of 5.